Whenever you have a color legend, you have an opportunity to build in a powerful interaction where if you hover or click on one of these colors or one of these items, that could filter the data to isolate just that thing. I like to call this interaction technique interactive color legend. We'll discuss mouse events, selection.on, state management for keeping track of which thing you're hovering over, the opacity attribute, color legend highlighting, the ternary operator, which is that crazy looking syntax with the question mark and the colon, mark highlighting in the scatter plot, and disabling text selection with user select none. I'll start by forking this example. I'll call it interactive color legend. And the first thing to do to make this work is to listen for hover events in our color legend.js. Here's our color legend component. This is the top level group. This is the text label. And this is the selection of all of the ticks. And each tick, remember, is a group element that has nested elements of a circle and text. Ideally, we would be able to hover over either the text or the circle to hover over that element. Therefore, I think I'll add the event listener on these tick groups. We can do that using selection.on. This is an API provided by D3 Selection and documented here under Handling Events. You can call selection.on passing the type of event that you want to listen to. For example, click or mouse over or any DOM event type. And there are lots and lots of DOM event types. For the hovering, I think we should use mouse over and mouse out. Or maybe mouse enter. These are two different kinds of events. Though similar to mouse over, mouse enter differs in that it doesn't bubble and isn't sent to any descendants when the pointer is moved from one of its descendants' physical space to its own physical space. This diagram shows mouse enter will be sent to each element of this nested hierarchy, whereas with mouse over, a single event is sent to the deepest element of the DOM tree, then it bubbles up until it's canceled or reaches the root. This is relevant to us because we do have nested DOM elements. Remember that these three tick elements are SVG group elements that contain children, the circle and the text. Ideally, we would be able to add an event listener to this group element and have that event listener triggered if you hover over either the text or the circle. Let's try both of these and just observe what the behavior is. We can say on mouse over and then pass a callback function as the second argument. This callback function will be invoked with an event object each time this interaction occurs. For now, I'll just say console.log mouse over. Now we can experiment and see what happens. If I hover over the text, it says mouse over. If I hover over the circle, it says mouse over. Okay, great. I think this is pretty much fine. Let's try the other one, mouse enter. If I hover over the text, it works. And if I hover over the circle, it works. Okay, so in this case, it doesn't really matter. I think I'll stick with mouse over, just because that's what I've seen most commonly used, and it works just fine. Now I'd like to figure out which one we are mousing over. Now this listener that we pass into selection.on will be passed the current event and also the current datum, D. Therefore, we should be able to accept a second argument, D, and console.log that. And now when we hover, it tells us which species we're hovering over. Now what we want to do from here is set some piece of state that keeps track of this hovered value. I'll call it set hovered value, and we can get that passed into our color legend component. And then we need to pass this in from viz. Oh, actually no, from scatterplot. So here's our invocation of the color legend. I'll pass in set hovered value, and that can be something passed into our scatterplot. Now in viz.js, when we call our scatterplot, we can specify what this is. And I'll define this above. Const set hovered value. This will be a function that takes as input, I'll call it d, which is the new hovered value. And I would like to change the state. So I'll call setState, passing in the existing state, and hovered value being d. Now we can destructure hovered value out of our state. And just to see if this worked, I'm going to console.log hovered value. Oh, next is not a function. Sorry. The API for this is we define a function that takes as input the previous state and return the new state. So let's see if it works now. When I hover, it says Setosa, versicolor, virginica. All right. From here, what I would like to do is make this visualization show which of these is currently hovered over. So that will include some styling changes on the color legend, meaning I think I'd like to just fade out the ones that are not currently hovered over. And also, I would like to highlight the marks corresponding to the hovered value. Let's start with the color legend change. Since the scatter plot is what calls the color legend, first we need to make the scatter plot aware of the currently hovered value. And I'll destructure that here. And then the scatter plot can pass that into the color legend. And then in the color legend, we can destructure that here. And then on these tick group elements, we can set the opacity to be a function that checks the value, and if it's equal to the hovered value, we want the opacity to remain at 100%, so this should be 1. Otherwise, let's fade them out and make the opacity maybe 0.2. Check this out. Now they're all faded out, and it shows the hovered value. All right, that's how we can implement a basic form of hover interaction. This syntax, by the way, is called the ternary operator, or the conditional operator. This takes 3 operands: a condition, meaning an expression that returns true or false, or something truthy or falsy, followed by a question mark. Then an expression to execute if the condition is truthy, followed by a colon, and then the expression to execute if the condition is falsy. It's a more concise version of if-else, pretty much. For example, here's a function getting the fee based on isMember, which is a Boolean. So if isMember is true, the fee is $2. If it's false, it's $10. And by the way, in JavaScript, a truthy value is a value that is considered true when encountered in a Boolean context, meaning, for example, in a ternary operator. All values are truthy except false, 0, -0, 0n, whatever the heck that is, empty string, null, undefined, and nan, not a number. All values except those are truthy. So if it's a string that's not the empty string, then it's truthy. If it's an object, it's truthy. If it's an array, it's truthy. So that's just a fun fact about JavaScript. I'm noticing a bug, which is if you hover off of it, or you don't hover over it anymore, it still remains selected. So that indicates to me that we need to handle another kind of event, which is when the mouse exits the space of these elements. To do that, I'll just copy paste this block that responds to mouse over and change it so that it responds to mouse out. And in this case, we should set the hovered value to be null. Now, if we hover over something and then move our mouse away from it, it's no longer hovered. But we don't want it to look like this when we load the page. I mean, I think it should only do this effect if there is a hovered value at all. Meaning, if we're not hovered over anything, everything should show as full opacity. We can tweak that by saying, all right, if there is a hovered value at all, then do this. Otherwise, return 1. So what this does is, if hovered value is not null or undefined, then we do the same check that we did before. And if nothing is currently hovered over, everything will be at opacity 1, meaning fully visible. And this is exactly the effect I was going for. Now, let's do the same thing for our marks. Over in our scatter plot, where we are rendering the circle marks, we can set the opacity to be a function of D, and keep in mind here, D is one row of the iris dataset. It's not a color value. So to get at the color value, we need to call color value of D, and that's what we want to compare against hovered value. So if it matches, we give it an opacity of 1, otherwise we give it an opacity of 0.2. And that worked. Now you can hover over these different values, and it highlights. But this suffers from the same issue we had before, where if we're not hovering over anything, it should be fully visible. And we can do the same check. If there is a hovered value at all, do all this, otherwise return opacity of 1. Now, it looks just like it did before, but then when we hover over the color legend, it has this really cool effect. There are tons of little improvements we could do on this. For example, making the hover cleaner by having an invisible rectangle behind it, or changing the cursor so that it doesn't look like you can select these text elements and actually disabling selection. But this is pretty much a nice first pass of an interactive color legend for a scatter plot. Also, this has this issue with the opacity, which is, I mean, it's kind of a cool effect, but if you want to really just make everything muted, ideally you wouldn't have this overlapping circles effect, like they would all be equally muted, and we could achieve that as well. One way to do that is to actually modify the color to reduce its luminosity instead of changing its opacity. I think I will work on a little bit of improvement here, namely on the text selection. First of all, I don't want users to be able to select the text. It just sort of feels weird. These sort of changes we could do either by changing the CSS or changing the JavaScript. In a way, it's conceptually simpler to just change the JavaScript, but it's up to you. So on the text element of our color legend ticks, I'll set the attribute user-select to be none. Now if I try to select it, it's actually still selectable. So I think instead of .attr, which sets the DOM element attribute, we can use style, which sets the inline style or CSS on the element. Now it works. Now I'm not able to select it. And notice that the cursor doesn't change to be that text cursor. I kind of like the way this feels more. All right, that's how you can add interaction to your color legend. let me do a quick review of all the changes that we've made. In the color legend, we respond to these different events: mouse over and mouse out. On mouse over, we set the hovered value to be the hovered color value, and on mouse out, we set the hovered value to be null. This thing, setHoveredValue, is a function that gets passed in our options object to the color legend from scatterplot.js. And scatterplot.js knows about setHoveredValue because it's passed in from viz.js. In viz.js, setHoveredValue is defined as a function that takes as input d, which is the hovered value, the color value, and then it calls setState, passing a function that takes as input the previous state and generates a new state object and returns it. This new state object has whatever was there on the old state, for example, the data, but an updated hovered value. Therefore, we can destructure hovered value out of state and pass hovered value into our scatterplot. Back in our scatterplot, we do pass hovered value into the color legend, and the color legend uses hovered value to figure out what the opacity should be on each of the ticks. If there is some hovered value and that tick matches the hovered value, it is fully visible. Otherwise, it's sort of faded out. But if there's no hovered value at all the ticks are fully visible. Also, in the scatterplot, when it renders the marks, it uses hovered value to figure out the opacity of the circles in the scatterplot. Using almost exactly the same logic, the only difference is it extracts the color value out of the row of the dataset using the color value function. And that's it. That's how you can implement an interactive color legend with D3 and unidirectional data flow. This technique, by the way, could be applied to pretty much any visualization technique that has a color legend.